have to have a semicircle. So that's exactly what I'm going to be drawing. Now there is a tangent that is given here. So there is a point of tangency over here, and there is also a tangent line that is actually hitting here, right? So I will draw it like this. So this is a point of tangency right here, and this distance is given as 9 units. Okay, 9 units, and I'm going to take this hit as t, and we are asked to find the radius r. So foremost, what I'm going to do is I'm going to take, let r be the radii of the small circle, and let capital R be the radii of the semicircle. Now PT is the tangent to the circle, so this means the radius of the circle will make an angle of 90 degrees to the tangent. So we can draw that. So this is going to be having a hit, and this is 90 degrees. Now I'm going to take this point as some S, and I'm going to connect P with S. So if we connect P with S, then P triangle PTS is right angled. So by Pythagoras theorem, what do we have? We got PT squared plus TS squared is equal to PS squared. Now this distance is R. This distance I'm going to take it as X. So this in turn would mean, see, this entire length is given as 9 units. So this is 9 squared plus TS is R squared is equal to PS, it's going to be X squared. 9 squared plus R squared is equal to X squared. So we have got that out of the way. Now we will have to have another triangle. And we will have to make the connectivity, okay, with the unknown variables. So we got an X, we have to get rid of that X, and we have to get rid of this R, and we should also create an equation involving capital R. So let's do that. Okay, next what I would like to do is I would like to actually draw a perpendicular from S to this radii. Definitely we can do that because it's a tangent there. So I'm going to mark that. So that would mean I can actually have the same length. The same length that you see here can be also marked on this diameter. So that would be somewhere over here, right? So now the next step is going to be, I would like to drop a perpendicular from S to this indicator, this point here. So if I drop that, we are creating a rectangle. Okay, it is not only a rectangle but is also a part of a triangle, and I'm going to take this particular point as sum A. So this is clearly R, so this will also be equal to R, and we know this is the radii, so you will have a radii over here also. Now I would like to consider PAS, so this is clearly 90 degrees, and I would consider PAS as a right angle triangle. Since triangle PAS is right angled by Pythagoras theorem, we get, so what do we get? We get PA squared plus AS squared is equal to PS squared. Now this PA is capital R plus small r. So capital R plus small r squared plus AS. So we will have to get this AS. Now what I wish to do is I will place this AS as some y units. So that's going to be y squared is equal to PS. PS is x. So this is x squared. Now this is equation 2 and we already have equation 1. So from 1 and 2 we get, so what do we get from 1 and 2? In place of x squared I can substitute this. So capital R plus R the whole squared positive y squared is equal to 9 squared positive r squared. So this is what we got. Now I'm going to take this as sum 3. Go back to the figure. What I will do is I will actually connect S with O. So if I connect S with O, I would have a triangle OAS. Now OAS is right angled. Now this distance is R, this distance is Y. Now what is this distance? Now if you were to stretch this, okay, you have to stretch this. Now there is a tangent here. Now this is the center. Now when two circles are having a point of tangency, if I were to draw a line through the center, it will actually go through the point of tangency. So that is a theorem in geometry. We have done a lot of questions with that. So that's exactly what I'm going to do. I'm going to connect and extend and use that theorem in geometry. So we have a point of tangency here, and we can take that point of tangency to be as sum B, and we can actually connect this. So this distance is R, this entire distance OB is capital R, and BS is small r. So what is OS? OS is going to be, from capital R you take away small r, that's going to be OS. Okay, so we would consider the triangle, OAS. So this is going to be OA squared plus AS squared is equal to OS squared. So OS is R negative R the whole squared. OA squared is R squared, and AS squared is Y squared. So this is what we got. Now from here I write Y squared to be as capital R negative R the whole squared negative R squared. So this is going to be my 4. So I can use 4 in 3. So let me go and write there. So what is 3? 3 is capital R plus R the whole squared positive Y squared is equal to 9 squared positive R squared. This is 3. And what is my 4? Y squared is equal to R negative R the whole squared negative R squared. This is my 4. So since we got that, using 4 in 3. So y squared is this, so therefore 3 can be rewritten. So 3 can be rewritten as capital R plus R the whole square. In place of y squared, I'm going to substitute this. So capital R negative R the whole square negative R squared is equal to 9 squared positive R squared. Right, so this is what we've got. Now we can expand these two things and simplify. So let us see what we are getting. So this is going to be R squared plus 2 times R plus R squared plus R squared negative 2 times R plus R squared negative R squared is equal to 9 squared positive R squared. Now positive negative goes off. Now you have an R squared here. This R squared and this R squared goes off. You got positive 2R, negative 2R goes off. Now you have R squared plus R squared. So that's going to be 2 times R squared is equal to 9 squared. Right. So R squared is equal to 9 squared over 2. So that means R squared is equal to 9 squared is 81 divided by 2. So R is equal to root of 81 divided by root of 2. Root of 81 is 9 divided by root 2. Now you multiply by root 2 divided by root 2, you get root of 2 with a 9 divided by root 2 into root 2 is 2 units. So this is the requirement, find R. So R's value is this, and that completes the solution for this question.